So I was saying that we already started last time, or actually finished last time, discussing wireless network and their characteristics in terms of the challenges in wireless communication, the technologies, the old technologies, the new technologies, the future anticipated for wireless communication. This is more or less what we were discussing in the previous set of lectures, like 3 lectures approximately, or should have been 4. So we need to take one compensation lecture, but we'll plan that later. Anyways, now we are going to discuss the wireless challenges of, the security challenges of wireless communication systems. So previously we discussed generally the idea of communication itself, what are the existing challenges in those systems, how they are solved with some different, like a few different technologies, and the perspective for that. Now we need to look at wireless communication or wireless networks and what are exactly the kind of challenges that are specific to wireless networks. I've explained before why wireless networks specifically are key to us or the focus of this course, because those are the ones that have security challenges and serious ones, right? Wired communication by nature happens inside a contained medium, right? It happens, the data is going through a wire. And for someone to read that data, they have to cut into the wire. And when they do that, it's going to be very easy to detect that something wrong is going on, right? On the other side, wireless communication is by nature broadcast. You send the signal, anyone can listen to it because it's an open medium, right? Any device hiding somewhere behind a wall or behind or underneath a table or whatever can still, without being visually detected, can still be listening to your information and maybe also able to read the actual information. And this is where the actual threat happens, right? So that's why we discuss wireless. Now, among wireless also, we will focus our discussion, and this is going to be also the focus of your first project, right? On Wi-Fi specifically. Why Wi-Fi specifically? For 2 reasons. It's widely spread and have easy access to it, to learn from it. That's the first reason. So for practical reasons, discussing things related to cellular is very difficult because getting access to a cellular network and seeing the internals and doing changes to that or playing with it is impossible. No carrier will allow you to do this. It's highly regulated, highly controlled by big firms and companies, and they don't want anyone to mess up with their system, right? Wi-Fi, you can just create a Wi-Fi right now, right? So because of the widespread and easy access, that's number one. Number two, reality is Wi-Fi is one of the weakest technologies, even though it's widely spread, it is the weakest in terms of its security. It has lots of threats, and the reason for that is not because the technology is bad. It's only because it's widely spread everywhere, and it's uncontrolled, it's distributed, right? We have a network here at the university, which belongs to the university. Each one of you has a Wi-Fi at home, which belongs to you personally. Nobody else is responsible about it, right? You manage it at your home, you do whatever you like, switch it on, switch it off, give access to other people, restrict other people from accessing your network, change the configuration, even though you bring some technicians to do that for you, but eventually they leave and you stay with your network, you can do whatever you like with it, right? So because of that, because of this widespread and distribution among different owners, it's one of the most vulnerable systems for security attacks. And that's why we will narrow down our focus into Wi-Fi specifically. We can learn a lot from that, and then we can apply this to other more secure networks that are easier probably, like quote unquote, not necessarily, that are easier to handle in terms of security, okay? So what are the objectives of what we are going to start to talk about today, and we'll finish it hopefully inshallah next time. We look at security threats. Again, this is the classical way of learning technology. So we'll look initially at what kind of security threats are there on wireless networks, wireless communication systems, and then accordingly we can figure out what kind of measures or actions you need to do to make sure that they are more secure, or to make sure that you are protecting those networks from those security threats. And as I mentioned earlier, this is the only way to learn security. Security is a slightly different domain. It's very practical, and you cannot really have it defined in a kind of theoretical framework and you build around that. Because of the practicality of this system, the way to learn it is to see what people can do bad to your network and then try to prevent that and fix it. So you always look at threats and then you figure out ways to overcome these threats, and the cycle keeps going, okay? Okay. So these are kind of the topics that we'll cover. We'll discuss the threats and then understand the unique ones that are not only for wireless, but mobile wireless. Mobile wireless is a special case of wireless, and we will learn why. And then we'll talk about the protections. And the last two parts, which are probably going to be covered in more details in the next lecture, we are going to talk particularly about the security of Wi-Fi, which is part of what you will do in your project, inshallah. Okay. This is chapter 18 in the book. So as I said, we are not going by sequence. This is not chapter 3 or chapter 4. So we finished 1 and 2. Now we jump to 18, and we'll go back to when we start discussing the cryptography, encryption and decryption. We'll go back to 3, 4, 5, and so on. Okay. So wireless security, the threats that are happening, or the higher risk in security and in wireless systems, is due to one of those 4 elements that exist in every wireless network. Okay, the first one is the major threat comes from the channel, because of the channel being broadcast in nature. So it's susceptible to eavesdropping. Remember what was eavesdropping? Someone trying to listen to your communication and try to figure out the information that you are exchanging, right? And not only that, because of the fact that the medium is open for other people to use it, then also wireless technology, due to its nature of the channel, is vulnerable to attacks that prevents you from getting the service, the denial of service attacks. A simple attack is going to be just to jam the receiver. So send a very powerful wireless signal towards the direction of the receiver, and accordingly the receiver is not going to be able to listen to any other legitimate user trying to communicate, right? So that's one attack that you cannot do in wired networks. You cannot do really a jamming attack. You can do denial of service by asking, like sending repeated requests so that you overwhelm the server, as we mentioned last time, but you cannot do jamming in a wired system. You can do jamming mainly in wireless systems, okay? The other reason for the vulnerability, the other characteristic of wireless network that causes them to be vulnerable to threats is the mobility. And why mobility imposes some threats, you can see here that one of them is very specific, the other one is very general. So the specific one says that for mobile devices like your phone or even your iPad, right, you need always to make them lightweight, right? So they have to be limited. You cannot really have a mobile device which is like 10 kilograms, okay? Which means that if they are lightweight, they are also light size. They are small size devices. What does this mean? It means that eventually they will have limited resources for doing anything, including implementing wireless technologies, right? So the fact that those devices are mobile imposes one threat on them, which is limiting the resources, and that's the third element here, right? Generally speaking, wireless communication devices in many applications, not all of them, but most of them have limited resources because of the mobility feature, right? The other thing which is imposed by mobility, or the other kind of risks, which says the mobility results in a number of risks, right, is the fact that you can actually move from one network to the other. So the idea of doing handoff, right, moving from one server to the next one, to the one access point to the next one, to the next one, makes you also susceptible to attacks, right? Because eventually one of those might be fake. But if you stay always connected to the same node, you already know that node, you have dealt with it before, so you know that it is trusted, and the only way it can be fake is that either someone comes and replaces it, and probably you are going to detect that when it happens, or that someone really breaks into that node and does something big to it, right? That's less possible as opposed to just connecting to a new node that you haven't connected to before at all, and then assuming that it is trusted. You don't know, right? So that's another, and this threat comes both ways. The same thing happens from the point of view of the access point. Every day there is a new user trying to get to this access point. There is a new student at Qatar University, there is a visitor, there is a new faculty, there is a new employee, and so on, right? So again, even the backbone of the network is susceptible to changing users all the time. Again, this is difficult to happen in wired network because they are fixed most of the time. And replacing one of the users means you really have to go and remove a computer or disconnect it or bring another one and so on, right? So the dynamics are much less, okay? So this has to do with mobility. While talking about mobility, we touched upon that wireless devices, particularly the mobile or the portable ones, are also limited in their resources. And one famous story that I've been telling you about also over and over again, the hacking that happened a few years ago in Internet of Things, which was mainly through coffee machines that are connected to the internet. These are coffee shop machines, and they are connected to the internet to provide some services, like, for example, monitoring the inventory and informing the supplier that I'm out of coffee, and predicting this ahead of time. Then the supplier comes and brings coffee before the machine stops working and the coffee shop cannot serve anymore, and so on. So they have connectivity, right? And the connectivity is autonomous from the machine directly to some server that does the services required. But again, those machines are designed to serve coffee. So the connectivity part of the machine is very limited in size and weight and consumption of electricity. It's a small component as part of the machine. And because those small components are limited in terms of their memory and processing capability, what happened is the implementation, not the actual protocol itself, but the implementation of one of the security protocols had to be done in kind of, it should be dynamic enough to change its registers that it deals with, but there is a limited number of registers on that machine, on the memory of that machine or the processor registers, right? So it had to limit the action to be only dealing with 2 registers. And accordingly, this caused the security protocol not to work as designed. And you can go and visit, like search this, hacking on coffee machines, IoT hacking, and you will get more details than what I'm saying, okay? And then accordingly, the protocol was supposed to be able to do something, but it's not. In actual implementation, it's not. It's limited to what it can do as opposed to what the actual scope should have been, and it was attacked from that point. So even though the design of the protocol itself is correct, but when it was implemented to be compatible with the limitations of the hardware, the implementation was weaker than it should be.
So they hacked the coffee machine?
Yes, and through it, they broke into some other, yes. Yeah. So it was the entry point to hack larger or more important stuff, okay? Yes? No question, okay. And then, last but not least, the accessibility, right? Accessibility here means what? Accessibility means, remember when we talked about wireless sensor networks? So those devices that are connected wirelessly to the network, particularly for the applications of wireless sensor networks, are left somewhere unattended. You go and put, for example, a set of sensors in the middle of the desert to measure some air quality, right? And because of the fact that there is no one around them, and there is no premise that protects them and prohibits physical access to the devices, anyone can come and just remove your device and replace it by a similar one, but malicious one, right? And then it will connect to the network, and you haven't seen the action because nobody is monitoring that area. It's very difficult to do this, for example, here. Maybe Qatar University is not the best example, but it's very difficult to do it in a company, for example, because anyone who gets into the company, there is security, there are employees, they will see the person trying to do something, they will ask questions. So that's a layer of protection, even though it's not a technical layer, but it is a layer of protection. So unattended devices that are accessible to many entities without any particular protection are more susceptible as well for security breaches, okay? So 4 areas: the openness of the channel, the fact that the devices are mobile, the fact that those portable and mobile devices will have limited resources in terms of computation and memory resources, and even energy resources as well. And last but not least, the fact that many of these devices are not physically protected. They are left and accessible to some unauthorized physical access to the device, okay? So these are the key features that increases the vulnerability of wireless network. A wireless network in general, and particularly an infrastructured one, whether it's Wi-Fi or cell phones, typically goes through, the infrastructured ones typically go through or has those 3 components. There is an access point or a base station in the case of the cellular system. There is a wireless medium that links between the base station or the access point. The wireless medium is the space between them. including which frequency they are using, what time they communicate at, and we call it the spatial or the physical propagation channel environment. Like are they are connected together wirelessly, but are they placed in like a place with high buildings, or are they in an open area like a highway going from here to North City, for example? Then it's a very flat area. All of these are properties of what we call the wireless medium or the channel. And then the other side is the client side. Typically, the access point side is more controlled. It belongs to the network itself. The client side belongs to the user. It's your cell phone, your computer, your laptop, your car, if it's connected to the wireless network directly, whether through phone in the car or through some other Internet of Things devices that are now in many of our cars, right? Okay. So these three components, in the next few slides, we will look at number one, generally the wireless network threats, and then we will focus on each one of those components and look at how to protect that specific component of the network from the possible threats on that components, okay? What are the possible wireless network threats in general? Remember, what we mentioned a couple of slides ago was the properties of wireless networks that causes them to be susceptible to threats, but we didn't discuss the actual threats, okay? The actual threats are the ones listed here. So there is accidental association. Accidental association means that you connect with the wrong access point, or you connect with the wrong base station, but unintentionally. So that access point or that base station was not actually malicious and hiding inside your network. It just happened that you passed next to it and you connected to it, right? Is that a threat? Yes, because you don't know whether this device is going to take some of your confidential information and spread it, even unintentionally. If you connect there, sometimes the device itself asks for certain exchange of information between the access point and your mobile device. And part of this information might be your confidential information, something similar to the name of your device, which is being used inside your private network, for example. So it's not necessarily your own personal information, but it's confidential information related to the device, right? So sharing that on another network is not supposed to be the case, right? There are many other examples to this. So that's one way. The other way is the intentional one. So you associate with a malicious access point, right? So that one is called malicious association. Now, one of the ways to hack users is to, like if I want to do that, for example, here, I will come in the middle of the night, nobody sees me, I will remove this access point, I will install mine that looks exactly the same visually, and also from a network ID point of view will look to you the same, and you come tomorrow morning, you get here, assume that I don't know what's the password that you use for your account, for example, to link to QU, you will come, assume that this is a QU, be asked for your password, you provide the password. Now I got your email password, because that's the same one that you use for QU user, right? And that was maliciously, intentionally done, and you didn't know about it, right? That's the option of malicious association. So that's another threat.
So it's in the point of view for the one that violate the Wi-Fi, not from our point of view. The accident.
You mean the difference between those two?
Yeah.
Both of them are threats, but one of them is a threat that's unintentional, in good faith, not from your own point of view. It's the other party who got your information. So there is another network that was not intentionally there to actually get your information, but it was around and your device connected to it and shared some confidential information with that network. Again, the network was not looking for that information, but the fact that the information became available in that unauthorized network is a threat by itself. Okay, anyone can use it in a bad way. Okay, the other one, no, it's intentionally a device that meant to deceive you and make you think that it belongs to your network, and you connected to it. You connected unintentionally, but the device was doing this intentionally. Okay. Third threat is, again, like remember we said that there is another mode of operation of wireless networks, which is not an access point and a client mode, but peer-to-peer mode. So we all have our iPads here, maybe iPads and laptops, and then we decide we don't have an access point, right? And we decide we want to exchange files and share pictures and whatever. In that case, we can just do a mesh or an ad hoc network, so our devices will start talking to each other without a central unit and share information. generally speaking, ad hoc networks is a big threat. They are vulnerable to attacks because a single user within a whole network can do a lot of harm. So now if we are trying to connect maybe 15 devices in this room, and only one of us is malicious, myself, for example, I'm always malicious, okay? So I'm sufficient to pose a threat on another 14 persons, right? Or another 14 devices. That's a big thing, right? And why in ad hoc specifically? Because in ad hoc by nature, we are talking about connectivity between devices or people or users who do not really know each other from a security point of view. They might know each other face to face, but they don't know exactly, there's no controller. There is no one to guarantee that everyone here has good intention or does not have the tools to harm others, right? And in case of controlled network with network administrators and so on, they are trying to make sure that even if there are someone who are trying to do harm, they cannot do it, right? But in the case of ad hoc, nobody is guaranteeing this. Just devices out of nowhere started talking to each other because they are in the same room, for example. Okay? And they want to talk to each other as well. Okay? So ad hoc networks in general is a big threat. Okay? Non-traditional networks, networks that are not in our day-to-day, even or they might be in our day-to-day, but they are very special. And examples of these is RFIDs, right? Or the near-field communication. You know that your card that you go and teep, you do it on a paying machine, right? This network is non-conventional. It's not really a famous network, but it exists. Not many people are aware that there is such a network. Many people think this is a Wi-Fi. It's not Wi-Fi.
The NFC.
Yeah, and it's NFC, near-field communication, right? Many people, they think, even when you go to stores, they tell you, are you going to pay by, you used to say, pay by Wi-Fi. It's not Wi-Fi, okay? Has nothing to do with Wi-Fi. Why non-traditional networks? Because typically those evolving technologies and non-traditional technologies are new. People are not aware that much about the possibilities of threats on those networks, and accordingly, people fall to many threats through those networks. For example, not here in Qatar, alhamdulillah, but very famous thing is some of these machines, they just put another extra cover on it, and when you bring your ATM card or your credit card, rather than actually doing the transaction and that's it, that extra layer captures the information and then starts using it to buy some other stuff on your card or do this or the malicious transaction and so on, right? So it's generally speaking, people are not that much aware about the threats that can happen there. So that's why those are part of the issue. I can tell you a story here. 2 days ago, and that was, by the way, by chance. And I was planning to get the person to talk to you here in the course in like a visiting lecture, but unfortunately he was not staying in Qatar long enough. I met a friend of a friend. We were having dinner in West Oak. Yeah, I remember the place. So I found out that he's working as a consultant for cybersecurity for companies. And his job is actually to go, gets hired by the company to try to break into the network of the company. That's his job. So, and then he submits a report, what are the weaknesses that allowed him to break into the company, right? And he was discussing some of the techniques that he uses for this. And he mentioned 2 techniques, right? One of them was related to Wi-Fi. So he said there was that company in Riyadh, he works in Saudi Arabia. Okay? And of course, I cannot mention the name of the company, neither him nor I, so I don't know. He didn't mention it to me. And they asked him to try to break into the company's internal network. Tried through all internet access methodologies, he couldn't, very well protected. So connecting here, there, going through the website, doing this, doing that, he couldn't. And then the last resort is that he drove his car and he came with a laptop close to the building of the company. And then he picked a Wi-Fi signal, tried to connect to the access point, he couldn't, so it was secure enough. But then he actually tried to hack one of the users, right, who was connecting to the network by doing something called repeated authentication request. So the user falls under the illusion that the access point is asking for the password several times. You put the password, right, through that attack, and then it actually goes to the access point, but then the other person who's doing that attack gives you as if the access point has responded asking for the password again. So you put it. And then repeatedly putting the password several times allows him to break the protection and figure out the password. He was able to figure out the password of one of the users, and through that, he broke into the whole network, right? That's one way. You mentioned another scenario that he was able actually to break into the company's security, but not really the network, but the entry to the company. So he passed with an RF sniffer, like an NFC or RFID sniffer device near one of the employees, right? And then you carry those in your pocket, or like what I'm doing right here, and if he just passes here, in many cases, he can hack into this and read all the information here. And if he does that, then he can record that information and go to any access point, open the doors. If this door is a control for a server, he can get into the server room. He can do whatever he likes. And his advice to me was, but I didn't yet apply that advice. He said that when you carry those things, you should use one of those, they call them NFC protection. So there are wallets that are made completely of a metal, right? And then you put your ATM cards and your credit cards and stuff inside those, so that if anyone passes, even if you bring it close to a machine, it doesn't work. You have to take it out so that it can be read, right? And he was carrying that in his pocket, so he knows the tricks, right? Anyways. Yeah. Okay. I'm not gonna discuss this because it has to do with the university, so I'm not talking about it. Anyways. No, actually, okay. Let me stop the recording. Anyways, going back to the threats, identity theft, and particularly the MAC address. Okay. So remember MAC address spoofing, or they call it MAC spoofing. Okay. Remember that most of these devices, or not most, all devices in the market, by regulation, are required to have a unique medium access control address. It's called the MAC address. Okay? And it comes in eight digits. Each one of them is a hex digit. 2 numbers, hex number. Okay. This is unique. So no 2 devices will have the same MAC address. And it's supposed to be fixed by the manufacturer. So no licensed device allowed to be imported in a country, or allowed to operate, or FCC approved, or CRA approved, has to have, if it's connecting to wireless, has to have a unique MAC address, correct and authentic, okay? Now the problem is, above that MAC address, to read that MAC address, you use a piece of software, which is a driver that runs on the computer. Some of those drivers are malicious, and they can actually report an incorrect MAC address just to fool other people that I am an authorized device, even though I'm not, just by reporting an incorrect or fake MAC address, right? How do you figure out a fake MAC address that allows you to get into a network? By figuring out what are the MAC addresses that are going into that network. And that's called MAC spoofing. So I try to capture the exchange of MAC addresses between devices that are authorized in this network. I know that they can access, and then use that to kind of pretend as a user that I'm someone else, okay? Man-in-the-middle attack, we talked about that. So a device which is sitting over there, capturing the traffic which is supposed to be going to an authenticated user, and then changing the information and then sending it to that authenticated user, so the user is receiving something wrong. It's receiving different information than what it should have received actually. That's called the man-in-the-middle attack. Another threat for wireless. Denial of service, we have discussed that, either through jamming or through repeated requests, right? Last but not least is something called network injection, which is simply the intrusion or attacks that targets wired access point exposed to non-filtered network traffic. So non-filtered network traffic means that you are allowing different types of traffics into your device. And then some of these types of traffics can be easily used to attack the node. For example, I'll give you an example for this. All devices that are using TCP/IP are supposed to be able to respond to a ping request, because we use those ping requests, right? There's a command called ping, and then you put the IP address, and we use that to measure the delay between any 2 nodes. So if I want to figure out how much is the delay between my computer and a particular Yahoo server, for example, if I get the IP address of that Yahoo server and say ping and put the address, it's gonna report to me that it took, for example, 3 milliseconds. It took 5 seconds. It took 1 second until it got a response from the Yahoo server. So it's a command that's used to measure the traffic across the internet, right? And it's useful. But if you allow your home Wi-Fi access point, for example, to accept ping commands, okay, you can be easily attacked for a denial of service, because someone could just run a loop that keeps pinging your device, and your device by nature, if it accepts the ping, it should respond so that the delay can be measured, right? And if you get too many of those, they are going to consume all your bandwidth and all your resources, and no one else is going to be able to do anything on your access point, right? Other than it's responding to the ping only, right? So that's a way that it can be. That's why most of those, when you get them at home, the initial configuration is that they don't allow ping. You are not a server, you are at home, right? So you're not supposed to be kind of someone trying to measure the delay from your access point, right? This is important when I'm dealing with a big server that I deal with every day, but another user, why? Okay? So that's why by default, they filter out any ping request and they do not respond to it. They do not allow that service to be asking for resources from the device and responses from the device, okay? Now, if you don't really protect your system from those kind of vulnerabilities, then you are susceptible to something called network injection. Some other malicious networks can start either getting into your network or denying the service to your network or doing some other harm to your network, okay? Oh, wow, okay. Type. So before going into this, yes, I have, based on the question that has been asked, please, I mentioned that Wi-Fi is weakest, right, among the wireless. On the other side, cellular system is the strongest because the system is completely controlled, right? Still, there are ways to hack into that, but much more difficult and much more complicated. And there are much less threats on the cellular system compared to the Wi-Fi. And this is why everyone is advised when you are doing, for example, very sensitive stuff like your internet banking, right? Do not do this while being on a public Wi-Fi. Do not do this, for example, using the Wi-Fi of Doha Festival City or Wi-Fi of Landmark or Wi-Fi of Park or a coffee shop. Switch your system off from the Wi-Fi so that it will use the 5G or the 4G, and then do your internet banking because these are sensitive information. And then after that, finish the internet banking session, go back to the Wi-Fi. But as much as possible, don't do sensitive transactions on public Wi-Fi networks. You can be attacked. Yeah, Qatar is not very common, but in many other countries it's very common. You can be attacked severely due to that, okay? So going back to securing the wireless network from those vulnerabilities that we have discussed, you have to secure the three components, right? So you have to look at securing the wireless transmission itself, the data while going through the medium. You have to also look at securing your access point, how to make sure that nobody has access to the entry point. These are entry points to your network. So you have to make sure that nobody has access through those entry points except authorized people. And you also need to secure your mobile devices, okay? And that's gonna be the last piece, and we'll spend a good amount of time talking about mobile devices, vulnerabilities, and security. So let's start by securing the wireless transmission. There are two major ways to do this. Okay, one of them, we have discussed it before. So making sure that your data cannot be read except with someone who has the key to decrypt the data. So you use encryption or you use cryptography to make sure that the information exchange is hidden. Nobody knows exactly what's the information, right, inside that exchange of communication, except the ones that are authorized by having a key to be able to decrypt what you have encrypted. Tamam? That's one thing. But there is another level of security where you actually make it very difficult for anyone to know that you are communicating in the first place, right? So you hide the signal itself. Nobody can detect that there's a signal going here, and if nobody can detect the signal, they cannot detect the information inside the signal. Much more difficult to do, but at the same time, it's a much higher level of security. So hiding the signal. Now again, hiding the signal from like a physical layer, actual signal point of view is challenging. One of the techniques used is, for example, use very low power, spread across a very wide frequency. They call that code division multiple access or spread spectrum communication. Okay, so the signal in general is let's say your signal has a power of 1 watt. Of course, this is a very large amount of power for communication. Okay, rather than having the 1 watt focused on 1 kilohertz, and it's with a level of 1 watt, right? You spread that across a few megahertz. The total should be 1 again. So this means that if you make it wider, you make the level much lower. Okay? Any user who doesn't know exactly how to gather back that signal into the original band, they will not be able to detect your communication. Okay? And how do you do that? You use a particular code to spread the signal. Anyone who does not have that code cannot de-spread it, so they cannot really collect the actual signal itself, let alone the information inside. Okay? That's one technique. There are many other techniques. This category from a physical point or physical signal hiding point of view is called covert communication. Communication that is hidden. Nobody knows that there is a communication in the first place. Okay? But there are other stuff that you can do that are very similar. So they are simple actions, but are very similar to hiding the signal. Okay? One of these is those devices, the access points of Wi-Fi, they have something called the SSID, right? That SSID is, for example, here in Qatar University is QU user, QU guest, QU secure user. There are 3 or 4 of them, the IDs of those devices, right? Now, if you hide that, right, and you try normally by any device to search of available Wi-Fi's, it's only gonna show you the ones that has a non-hidden name. The other ones are not gonna show in the list. So how do you connect to them? If you know the name, you write the name, the network appears to you. So you say connect to show devices, it will show you the list of the ones that are broadcasting their ID, right? And the ones that are not broadcasting are not gonna show up, but then there's an option that says connect to private network or connect to special network. There's one more option. You click that, it asks you what's the SSID. If you know it and you type it down, then the network will show up for you. So that's one way to hide your device from like trivial attacks. Nobody knows that there is a Wi-Fi here, so nobody is gonna attack that Wi-Fi. As part of that, when you hide the name, try to make the name difficult. So if, for example, I have the Wi-Fi, and by the way, I'm very careless about security. So my Wi-Fi at home is not, I did not hide the SSID, and I call the SSID Egypt, right? So anyone who knows me, okay, probably it's either Tamer or Egypt. So they come across there, they will try at least those 2 names, even if I hide the name, right? That's trivial. I mean, I should be doing something like crypting the name. So, for example, using exclamation mark instead of I, using $sign instead of S, making the name difficult to guess, right? That's another level of hiding, okay? Another way is simply your Wi-Fi, generally speaking, does not come with a very high power. And even if you reduce that a little bit more, it becomes very difficult to pick the signal from outside the house, right? So reduce the signal. Of course, there is a limit where you can do that, because otherwise the service inside your home is gonna be bad as well. So you go to some rooms, you don't have Wi-Fi at all. So you need to keep it as just sufficient for a good service, and as much as possible, not too much to leak outside. That's another way of protecting your system. Of course, you don't do that and then you bring your access point, and instead of installing it in the middle of the house, you install it just next to the window here. So now, no matter what you do, the signal is going to be stronger outside as compared to inside, right? So also locate the device smartly inside your house so that your walls are providing some protection that your signal cannot be detectable. Why do you care about outside? Because outside is where malicious people can be. People that you let into your home are not supposed mostly to be malicious, right? And you see them and you can know what they are doing, so you have control over them, okay? So anyways, the whole idea here is there are some measures that you can do, both to hide your information, that's the second option, or even at a higher level or a more stronger level to hide your signal itself, okay? That's the security of the transmission, okay? Securing the wireless access point. What is the main threat for wireless access point? Is unauthorized access. And the way to secure the wireless access point itself is to make sure that it's not open wide. Only people who have a password or have particular MAC addresses or have some way to authenticate with that access point are the ones allowed to get into that. And for this purpose, there is a whole set of standards, the 802.1x, okay, which is about the security and the authentication of the access point. And we'll discuss that when we start discussing the IEEE 802.11 in the next lecture, inshallah. Okay. Securing wireless network in general, these are nice advices for securing wireless networks. Use encryption. Again, security is not only about information, there is also the security against malicious software that can come into your equipment. So use an antivirus, an anti-spyware. Turn off identifier broadcasting, the SSID broadcasting, right? Change identifier on your router from the default. Identifier, ال SSID.
لا لا اللي هو اللي turn off identifier broadcasting اللي هو SSID.
Identifier هو ال SSID. So the SSID is by default is broadcast by the access point to be discoverable, right? If you want it to be not discoverable, you stop that, you hide that, okay? Interesting one, change the identifier from the default, because even if you hide it, but you keep it at the factory default, everyone knows that. By knowing which brand you are using, they can figure out what's the identifier, right? And don't forget to change password from the default passwords. That's on your computer, your phone, your Wi-Fi. And again, I'm gonna stop recording here and tell you something, but okay, back. So change the defaults, because defaults are very easy to discover. And last thing is allow only specific computers. So if you go to the configurations of those access points, you can say that I allow a certain list of MAC addresses. And then any other device, even if they provide correct username and password, they cannot log into the network because the MAC address is not authenticated, is not authorized, right? How do you do that? Again, one way to do it, rather than just going and reading the MAC of every single device, just the first time you bring your router, open all your devices at home, make sure that they are connected, and then get a list of the connected MAC addresses, and then mark this list as the only authorized list. That's it. And whenever you get a new device, you have to add it manually.
Actually, I have a question. When we connect to the QU user network, it asks to register the device itself.
Yes.
So that's the...
That's the MAC address registration. And if you go to that, they call it Wi-Fi connection center or something like that,
Yes.
you will find that you are allowed a certain number of devices, right?
Correct.
And if you go there, you will see that each device is identified by the MAC address, that like 8 digits, some 2 digits and then a colon, and then 2 digits and then a colon. That's the MAC address.
Okay, that connects the hardware.
Yes, so it makes sure that this device is allowed into this network. And even if you provide a correct username and password, but you don't have a registered device, it will not allow you until it's registered. And if you reach the maximum number, it will ask you to remove one before allowing another one in, right? So that's the last point, okay?
About the default password, is it the one that was
For the router, there's a default admin password, typically admin. Most of them, they come with admin as the router at home. So you secure your network, you make sure everything is fine, but you forget to change this from the default. Anyone who wants to hack into your network will come in, connect to the Wi-Fi, admin, and now they can change the configuration of your home, right? So make sure you change the default. You don't keep the username or the password, the default, okay?
الماك ادرس ونفس الواي فاي ادرس.
Yes, yeah,
طيب الصح ان احنا قلنا ان كل كومبوننت بيكون لها ماك ادرس.
yes.
طيب ليش بس في ماك ادرس واحد في الجو؟
لا.
بس الواي
لا, this is only for your Wi-Fi.
فاي.
So if you look for Bluetooth, you will find another MAC address for the Bluetooth. Yeah. Okay. So for each technology, there is a MAC address. Okay. Mobile device security. That's a big issue. Why? Because mobile devices, by default, are like they have all the bad things that we mentioned in the previous slides. Okay. They are limited in resources because they are mobile. They are uncontrollable. You cannot just say, okay, I give you, typically nobody gives you the mobile, you buy it, it's your personal device, right? And then nowadays, everyone is using them. Like for example, here at the university, you always check your Blackboard and your registration and stuff like that from the mobile. It's easier, handy, you always carry it in your hand, as opposed to opening a computer or a laptop and sitting, waiting, connecting, and doing all these things, right? But at the same time, the same mobile device in a couple of hours might be also connected to Costa coffee shop Wi-Fi somewhere in a mall or in a park, right? And probably that Costa coffee shop is not secure enough, the Wi-Fi there, and someone might have been able to put spyware on your device or hack some information from your device, and then after that happens there, you bring it back, you log into the network of the university, the device still carries those malicious things unintentionally, right? So because of that dynamics and mobility, and at the same time, the limited capabilities, even though these devices are no longer limited, but they are still, compared to an actual computer, they are limited in terms of the capability, they are vulnerable, and they take that vulnerability and they bring it to the network, right? So you have to be very careful when it comes to mobile devices, but at the same time, you cannot prevent them. They became an important key factor of our life. So no way to say I'm gonna prevent my employees from using their mobile, except, for example, if you work at the CIA or some like very, 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 very high security entity, but any regular civilian entity might not be able to do this, okay? To get work done efficiently, you have to allow mobile devices. You see here a list of the security threats that are specific to mobile devices, okay? Lack of physical security control, because you cannot just tell people to leave their cell phones at work because it's connected to the network and go home without it, right? So you cannot really keep it in premise. It can go outside and come back. When people go outside, they might even lose the mobile device, right? It can be stolen, or it can be lost. And in that case, it might carry some sensitive information. So since you are allowing those mobile devices to get into your network, your plan should be that you provide the security actions that also takes into account that these devices might be lost. So how do I make sure that if they are lost, my information, my insider information, my private information, not as a person, but as a company or as a network, which exists on those devices, are not accessible to those who stole the device or found it somewhere. Okay, one way to do this, the simplest, for example, now, is that those devices, they have to have a password, right? And that password, you are not supposed to tell it to everyone, okay? So if you lose the device, if the person gets that device without really figuring out the password, they will not be able to read any data. And not only that, remotely you can actually destroy everything, just disable the whole device, right? If it was connected. If it's not connected, you cannot do much remotely. So that's one thing. Use of untrusted mobile devices. You have also, so all of these are considerations that as a network security engineer, allowing mobile devices into the network, which is something practically impossible to prevent, you have to keep them in mind. So the other thing is that those mobile devices, some of them might be, the device itself is untrusted, right? Someone who got yesterday, for example, found a phone, very nice phone for free from a friend, and he took it and he started using it inside the network, not aware that that friend was actually putting some spy stuff into the device, and then it gets into your network, okay? So you have to assume by default that these devices are untrusted, because you don't know what happens to them, where they come from. Also, even the device can be trusted, but as I mentioned, the example of Costa, they might have been to some untrusted area, or have been connected to some untrusted networks, okay? So I have to keep that in mind. What are the threats that might happen because they might be connecting to an untrusted networks, and then how I prevent these threats from being used against my network, okay? Use of untrusted content. The example that I mentioned of the spyware, right? So maybe even through my network, those guys were trying to access some website or clicked some link that caused the device to carry an untrusted content as well. Location services are enabled on all these devices, and locating a person might be a security threat by itself. Okay, so one example is, I know that this guy, for example, is the server room responsible person, and if the location services is enabled and accurate enough, and I want, for example, to attack that military entity or that security entity, particularly the server room, now by tracking the location of that person, I can figure out where is exactly the server room, because he's the one who goes to that room most of the time, and then accordingly I can do a pointed attack to that particular room just by knowing the location, right? So location itself, when it's revealed, is a threat. Interaction with other systems, similar to access to untrusted networks. So an example of that is, and those guys, they have all our information now. They know about us more than we know about ourselves. Example of this is all of us are using Dropbox, Google Drive, Cloud, iCloud, and your information is all over the place, right? Your Gmail, your Google Docs, your
Even
Google
password.
Drive. Yeah, not only password, they have lots of information because you have personal documents, pictures, government issues, IDs, photographs. All of these are shared across these places, right? I mean, how much they use that information, we don't know. How much leakage is there, we don't know, but we have to live with it, okay? Last but not least is use of application, and particularly here we talk about cracked software, for example. So use of applications that are created by unknown parties, right? So these are, you don't know exactly what kind of applications are being installed on those devices, and you have to assume that some of them come from unknown source. So how do you protect your network from those if they become malicious at some point, okay?
Is it like agreeing to the terms and conditions without reading it?
Which one?
Yeah, the last one, unknown party.
Not really. هي similar to how many apps you install in your cell phone. A lot. Some of them they come from an authentic source. Some of them you just pick them up from some web pages, right? And those ones that are picked from web pages, you don't know the person who created them. Is it a trustworthy person or not? Which means that is the software trustworthy or not? And then a network administrator having your device with that software on it, they have to assume that you might have some malicious software on your device, not spyware. It's an actual application, but created by an unknown entity that might have access to some sensitive information on the network. So they have to assume this might happen and protect against that, okay? So it's slightly different from, that's another issue. So our information is everywhere, and our consent to give up all our money is everywhere as well, right? Because we say agree without reading anything. Last thing, and I will stop here because we are already at 3:15. This is how a typical protected or secure wireless network should look like, okay? This is an outside device. This is a mobile device or a device trying to connect to that network. Number one, you have to make sure that the connection itself is secure. And this happens through VPN. If the person is physically outside the network. So if you are connecting from inside the cloud, then you are physically inside and you can connect directly, and that happens here at Qatar University, for example. If you are sitting at home and trying to connect to some internal information, not the web page, because the web page is an external interface, right? Some internal information, it will require you to use VPN to be able to connect to that. Like, for example, access the license of whatever software, or do this or do that, right? So the other thing is a firewall. Firewall is mainly meant to prevent certain services that might be harmful and unnecessary for your network. The example that I gave on that is allowing the IGMP or the ping request, right? As Qatar University, I might actually opt for just blocking any ping request to make sure that nobody can attack me from that service, from the ping service, and then cause a denial of service to my network, okay? It should include an authentication and access control server. That's the one that asks you all the time when you want to connect to something in the network for your username and password, your email and password, right? Also, it should have mobile device configuration service. So if your mobile device is connected to that network, it will not allow that connection until it does some configuration to your device to guarantee that it cannot do harmful things to the network, okay? Does not happen that much here at Qatar University, but an example of that is when you roam with your cell phone from one country to the other. Sometimes you go to another country which has a roaming agreement and you configure your passport or whatever so you can roam and enable roaming, but then it doesn't want to pick the network. You click on the network, it keeps trying, doesn't want, and then after a few trials, you will get a notification telling you that, do you want to install the configuration of this network? And when you say yes, then it configures your phone different from what it was configured on Ooredoo or Vodafone here, and then after that you get the roaming connection activated, okay? So these kind of configurations, if you want a really secure network, you should provide kind of something that does not allow the device to link to the network unless the device accepts those new configurations, okay? And last but not least is application database, the one that controls, like this is the first point of entry. And there is always a single point of entry to any device connected from outside. Single logically. It might be many computers, but logically they are grouped under one single point of entry so that you can control the entry to the network. Nobody can get to the network from any other possibilities, right? This is kind of how a secure network should